You know how to make ketones from secondary alcohols. That goes back to chapter 10. And those chapter 10 reactions are definitely going to have utility as we get into really delve into the aldehyde ketone chemistry, because often you need to make your aldehyde or ketone via oxidation of a suitable precursor alcohol. So here we have a ketone. Ketones can be made via oxidation of secondary alcohols. That goes back again to organic 1. That's an important reaction to remember from organic 1. Here's our new carbon-carbon bond. Well, if you think back to what we talked about just on Thursday, we saw on Thursday that you can make alcohols via Grignard addition to an aldehyde or ketone. If I take that Grignard reagent and this aldehyde, I will get that secondary alcohol as a racemic mixture as the chiral center, but ultimately that doesn't matter. I'll get that secondary alcohol as a major product. Making alcohols via Grignard addition, what we've done is we've basically increased the degree of substitution of the carbonyl carbon by a factor of 1, a degree of 1. So we're almost back to one of ours. We can always make the Grignard just by the organohalogen exposed to magnesium. So bromobenzene immediately gives us that Grignard reagent. Got to do a little bit more work to get to this aldehyde. But again, you can make aldehydes via oxidation of primary alcohols. And then you can make this primary alcohol directly from an alkene. Requires some organic 1 chemistry, but we're continuing the story. Draw this in a slightly different orientation. What reaction conditions do we have to use to selectively put the OH on the less substituted carbon of an alkene, the hydrogen on the more substituted carbon? That's borane, hydroboration oxidation. First hit it with BH3, then in a separate step, it's usually H2O2, sodium hydroxide in water. That goes back to, I believe, chapter 6. How do we stop the oxidation of a primary alcohol at the stage of the aldehyde? PCC, beautiful. Pyridine chlorochromate will stop the primary alcohol. Any of the other oxidizing agents will go all the way to the carboxylic acid. So we can make that primary alcohol, or that aldehyde, by PCC oxidation of the primary alcohol. Then what we've got to do is we've got to hit that aldehyde with the Grignard. I'll write the and have it come in like this. If I take my bromobenzene, hit it with magnesium and an ethereal solvent, I'll get that Grignard, work that up, aqueous acid. I will get this secondary alcohol. And then all I got to do to get my target is take my secondary alcohol. What oxidizing agent will take a secondary alcohol, oxidize it to a ketone? PCC works. Any of the oxidizing agents that, so you can use PCC, you could use chromic acid. lots of different oxidizing agents that'll work. So, that's not as restricted because once you get to the ketone, the oxidation is going to stop. Okay. So the point is that there's only one synthesis on the test. There will be a key step that includes new chemistry, but it's impossible to avoid the organic 1 chemistry. It's just the nature of the subject. That's why it's so interesting. That's why, in a lot of ways it's so beautiful, because you start to take all these transformations and you start to be able to put them together to build up these rather elaborate and complicated structures. So that's kind of where we're headed. What we'll start getting into this week is really the meat of the carbonyl chemistry, the aldehyde ketone chemistry, and you'll really start to see just how versatile those compounds are in synthesis. Any other questions before we call it a night? All right, well, the best advice I have is work problem, practice makes perfect. Get a good night's sleep on Tuesday. You certainly don't want to see the test dead tired. I will see you guys in the lecture on Tuesday. Have a good night.